NASA's Launch Services Program, based here at KSC. It's responsible for delivering uncrewed spacecraft like weather satellites, telescopes. Many of those end up orbiting the Earth, but PSYCHE is going to go much farther. NASA's Daryl Nail spoke to an analyst about PSYCHE's unique trajectory into deep space.
Jermaine Oliver, good to see you again.
How you doing?
Well, this is your animation here. You're the LSP trajectory analyst. Show us now what is happening here with the second stage and the PSYCHE spacecraft on board.
We have the second stage and the launch vehicle together, and we're going through our first burn. This burn is going to get us to park orbit. During park orbit, we will basically loiter there until the trajectory lines up to get us on an outbound cruise to PSYCHE.
Okay, and so now you're going into that park orbit, and I notice this thing's moving around a little bit.
Well, we want to keep the sun about a 90-degree angle, but at the same time, we're doing what we call a barbecue roll, where the spacecraft will just spin to keep the temperature gradient across the spacecraft and the launch vehicle the same. You don't want the sun focusing on one particular area that could potentially damage any instruments or any hardware.
So it is continuing on the velocity vector, which we see here very clearly, and that 90 degrees to the sun. This is a long coast phase.
Yeah, about 45 minutes or so before we actually get into the injection burn.
Is there anything happening during this coast phase?
No, we're just pretty much just going through the barbecue roll, tracking the sun, keeping it 90 degrees away.
We're approaching now southern Africa and crossing that continent, but then getting ready for that second burn.
Right. When we finish crossing over the continent of Africa, then we'll start getting ready to do that injection burn where the vehicle will get into another attitude that will line up with the velocity vector.
And is that why we're seeing it start to swing back around?
Yes, you're starting to see that swing a little bit slowly right now.
Now the sun is on the other side of the Earth and starting to get into a shadow, so we'll actually be in darkness here as we approach the northwestern coast of Australia.
Correct. But that's not a concern to us. We still want to maintain the barbecue roll, as you can see. And as you can see right now, we're actually lining up to get to that velocity vector. And once we line up with that, we'll perform that injection burn.
All right, we see it now in the dark side of the Earth, starting to point into that velocity vector that you mentioned. And here comes our second burn.
Yes. You're about to see the second burn happen right now. It's about 2.5 minutes. This will inject us into the orbit that we will need to get to PSYCHE.
Second engine start, number 2. Your animation has a little vibration there as the engine's giving it the go, and then it cuts off.
Yes. And now, after this burn is complete, we will then get ready to go to the separation attitude. So you see the launch vehicle and the spacecraft get into an attitude where when we separate the spacecraft, the launch vehicle can then go into another attitude and perform a burn to get it away from PSYCHE.
I see it swinging back around, and here you've labeled PSYCHE separation.
Yes.
This is the moment where the second stage comes off the spacecraft.
Yes. At this time, we have separated from PSYCHE. PSYCHE is on its way. The launch vehicle is now performing a burn to get itself away from PSYCHE to include recontact, and PSYCHE will be on its way shortly.
Great. We don't want to run into the second stage with the spacecraft. It's got a job to do. And first, it's going out towards Mars.
Yes, it's going to do a Mars flyby to get that gravity assist, to slingshot itself over to the PSYCHE asteroid.
Help save fuel, get out to its destination. That's all a good thing.
Yes, sir.
Jermaine, thanks for showing us that. Really
Thanks for having me.
Appreciate your time. Good call out that the Falcon Heavy is in startup. Now we're going to get the go at T-minus 45 seconds.
Go for launch.
We are go for launch. All systems are go to send the PSYCHE spacecraft to deep space.
30 seconds. $15 seconds.
And here we go with the final seconds of launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of Falcon Heavy and PSYCHE on a mission to a metal asteroid in deep space to study the building blocks of our planet's inner space.
Vehicles pitching downrange. M1D chamber pressure is nominal.
View there from the onboard camera on the booster. Beautiful shot there as it goes through the clouds.
Power and telemetry nominal.
Over here, Gerald, the power telemetry are nominal. We're also looking at the data for all 27 engines.
Falcon is supersonic.
All chamber pressures look good, and Falcon is supersonic now.
Throttling down in preparation for max Q. A moment of peak mechanical stress on the rocket.
What will happen here
Max
is
Q.
the side boosters will be at full power, and the center core will be at a reduced power to go through max Q to reduce the pressures on the structure of the launch vehicle.
Coming up in 30 seconds. We'll start getting ready to have those boosters cut off.
Vehicle's looking good, pitching down range. All telemetry looks really good so far, Daryl. As we see a beautiful view of the Falcon Heavy and center core and side boosters there. Data is looking really good.
All 27 engines of the Falcon Heavy putting down 5.1 million pounds of thrust. Standing by now for booster engine cutoff for those side boosters. The center core booster will continue on.
Booster engine cutoff. Side booster separation confirmed.
Great shot there of the side boosters
back
coming
there.
off the rocket.
MVAC engine chill has started.
And there we start the chill on stage 2 as we get ready for MECO on the center core. Stage 2 will continue chilling down, making sure the fuel and propellants are flowing through that MVAC, getting ready for ignition.
Those boosters will have 3 burns, 2 re-entry burns and 1 final landing burn before it comes back down at LZ1 and LZ2, landing zone 1 and 2 here at the Cape. Next up is main engine cutoff of that center booster. After that cuts off, there'll be a series of steps that will happen in close succession. Main engine cutoff. The center core stage will separate, and then we'll start the second stage burn, the first of 2 burns today.
There we see a shot inside the
shutdown.
that was a shutdown.
Looking
Main
now
engine
inside
cutoff.
the booster. There you have MECO,
Stage separation confirmed.
and there it goes. You're looking at the second stage in front of you, lighting up its
MVAC
MVAC
ignition.
engine. Split screen now on your right-hand side.
Center core FTS is saved. Bermuda.
Calling out the communication stations. What a beautiful shot there, while we had it, of stage 2.
Daryl, we continue to look at the side boosters.
Bearing separation confirmed.
Boostback has been completed, and they're in extended coast right now.
And there go the fairings. Revealing PSYCHE to the atmosphere. You can see the fairing falling away back to Earth. SpaceX has their recovery vessel.
Vehicle is on a nominal trajectory.
Their recovery vessel, Bob, is out in the waters right now, looking to recover both of them. Getting a good burn now from the second stage. This lasts about 4 minutes. We are going out over the Atlantic Ocean, heading south towards southern Africa. On the right-hand side, you see the glowing engine of the Stage 2. We've got 2 cameras there. On the left, we're tracking those boosters coming back down.
Yeah, we should see in about 20 seconds, we should see the booster entry burn, which is be the one engine on both side boosters.
Quite a clear image in space on the right-hand side. We've got clouds overhead on the left, but you can see at the center, we're tracking one of those boosters, also tracking the second stage, it looks like right there.
Yeah, all the data so far, telemetry is looking nominal. I see the telemetry chilling down the engines for that booster entry burn on the side boosters, starting up in the telemetry. Everything's looking nominal. The vehicle second stage is performing very well, and side boosters are coming back.
Boosters entry burn startup.
And there we just heard booster entry burn startup is happening. And seeing the entry burn getting ready to go on the side boosters.
Boosters entry burn shutdown.
And there we saw the booster entry burn on one and shutdown. And there we see booster entry burn on the second side booster and shutdown.
Next burn is the final landing burn. And for folks,
PYNY FTS is saved.
and for folks who are in the area, you end up hearing that loud sonic boom, that thunderclap, just about the time they make landing.
Stage 2 is on a nominal trajectory.
You and I here at Hangar AE, just a couple of miles away from this landing zone, we certainly hear it and feel it.
Yep, and I see now that the side boosters are supersonic, transitioning to transonic.
And that's a shot of the booster through a thin layer of clouds.
We hear the call out for transonic. Landing burn is started.
Terminal guidance.
Here it comes.
I don't know, Daryl, but that sonic boom was great for us. I'm sure Jim is excited over there. There's the second one. I'm sure the host desk over there is feeling that really well.
Literally, our monitors were shaking as both those boosters broke the sound barrier.
And we just heard booster landing confirmed, as we see on the screen, both
back
landing
shutdown.
zone 1 and 2. Everything looks great. And then the call out for
Stage 2 FTS is safe.
PSYCHE 1, Stage 2 engine cutoff. So, Daryl, this will put us into that 45-minute coast that you and Jarmaine were talking about, allowing us to do
Nominal
that
park
barbecue
orbit
roll.
insertion.
Absolutely, we're looking forward to that. And as you look at your screen there are the two side boosters on their landing pads, coming down more staggered than I'd seen them before, but nonetheless, perfect landings for them both. And now we will continue to track this right here, the second stage of the Falcon Heavy, along with the PSYCHE spacecraft right there looking forward. You can see the spacecraft on the right-hand side. It will be coasting now for about 45 minutes. And when we come back, we will bring you the moment of separation. In the meantime, we'll send it back to Megan and Jim at the host desk.
And if you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw a Falcon Heavy rocket launch off with PSYCHE, the spacecraft. Jim, speechless. Speechless. Actually, you weren't speechless during the launch because you were standing next to me, and he just kept on saying, "Go, baby, go!"
Oh, it was so powerful, so incredible. Just, the light, the sound, you felt it in your bones, just shaking us as this thing goes up.
I saw
What
the
a great-
range of emotions. Like, you were super excited, and then you got quiet. You got really quiet.
Well, there's a lot riding on this for the whole team, right? For all the
Yeah.
hundreds and thousands of people that have been involved with this. And it's just, what a great ride so far.
Yeah. How did
Yeah.
you feel also hearing and feeling those sonic
Yeah.
booms? I was kind
Boom,
of worried
boom.
because we saw it in the video, and we were like, are we going to feel it here? And all of a sudden, boom, boom.
Yeah.
boom.
That was very exciting, very exciting. So, and it's just great job landing those boosters because we want to reuse them for Clipper next year.
Yeah.
Yeah.
Anything you want to say to the team? Again, as we just saw it lift off, you said all that hard work, all that time.
Yeah, no, this is just, it is a team effort, and, we're going to be collecting this data set and studying this planetary core for future generations.
Yeah.
Really, it's going to be spectacular. Data, images, chemical data, magnet field data, gravity data, and really, you know, we can't study the Earth's core any other way. So here's maybe how cores grow and what's happening inside our own planet.
Yeah. So
Expected
the
loss of
PSYCHE
signal
mission
per
is
meter.
going to explore the metal-rich asteroid, also named PSYCHE. And why don't we take a closer look at PSYCHE now? It was first discovered in 1852. We don't know exactly what the asteroid looks like, but scientists have combined radar and optical observations to generate this 3D model you're looking at right now. Shaped like a potato, at its widest length, it's 173 miles. That's about the same as driving from Houston to Austin, Texas. There's evidence of 2 crater-like depressions. It appears to have a significant amount of metal, and a day on PSYCHE lasts only about 4 Earth hours. So as PSYCHE's imaging lead, tell me, when can we expect the first photos?
We have to spend, once we complete the deployment, we have to spend many months just checking out the systems, propulsion system, communication system, computer system, everything, right? Communications. And part of that is checking out the instruments. So I think the magnetometer might get checked out first because they're trying to detect some of Earth's magnetic field before we get too far away. And then in the weeks after that, we'll be testing out the imagers, taking pictures of stars, calibrating the cameras, getting the geometric correction just right, and getting ready for our eventual flyby of Mars, where we'll get lots of more great pictures as we pass by Mars. And then, of course, we'll start seeing PSYCHE as we get close to the end of this decade in late 28, early 29. It'll go from that point of light that we can see in telescopes to its own little world.
Yeah, the fact that right now it's so far away, again, orbiting the Earth between Mars and Jupiter, 3 times farther from the sun than Earth is, to be able to study it now up close, that's amazing.
It's very exciting, right? Yeah.
And the fact that we're going so far out to learn more about our home planet, I think that's so fascinating.
It is, and I love the fact that, you know, this is something we're going to share with the whole world, right? It's a point of light in the sky right now, but we're going to see it become a world as it gets bigger and bigger in the windshield as we get closer.
And Lori Glaze, thank you for being here. We are so excited. So we are in Asteroid Autumn, but no 2 missions are the same. Nikki, tell us what makes PSYCHE unique.
Well, first of all, PSYCHE just launched. So, I mean, it's right, awesome. So, but PSYCHE is going to a metal-rich asteroid, and there are only 9 that we know of in our solar system, but PSYCHE is huge compared to the other ones. It's the size of Massachusetts. So we're going to go and actually visit a metal world for the very first time. We don't know what we're going to find, and that's what's so exciting about NASA science. Every time we launch a mission, we do unique, cutting-edge science, and this one is going to be absolutely no different. We cannot wait to get that out there, that spacecraft out there with PSYCHE.
Exactly, that was the perfect way to characterize it. We keep doing unique first. So actually, Lori, you were just in Houston as well as the administrator for the unveiling of the OSIRIS-REx sample return. So what are we finding with that mission? What is next?
That is an amazing mission, and as you said, I was just in Houston 2 days ago on Wednesday. It was absolutely spectacular to be there and share with the entire world kind of our first look at what that sample is. But really, it's the very beginning of the analysis process. We've got so much incredible science to do, but what was so unique about that particular sample was we're finding water in the sample. We're finding carbon, an incredible amount of carbon, more than we've ever seen even in the meteorites that we have here on Earth. So there's just so much new discovery to come. Keep tuned on OSIRIS-REx over the next several months, and I'm sure there'll be a lot more great new data.
Exactly, and we're actually not at the end of Asteroid Autumn yet. The Lucy mission is about to have a close flyby, its first asteroid encounter since launching in 2021. What are we looking to find from that?
So again, we're going to be going to an asteroid. It's a little one, so it's very, very different from Bennu, and it's different from PSYCHE, and we're just going to learn a lot because it's going to be the very first time that we've actually visited this new world. It also gives us an opportunity to actually check out the instruments and make sure everything's ready for when Lucy actually gets into the Trojan belt and starts the flybys in there. And I have to just give a shout out to DART. It's also part of Asteroid Autumn, and we just celebrated that 1-year anniversary of smacking that on the nose. But Laurie is going to tell you why Lucy is so important.
Yeah, so the Lucy mission, as Nikki said, of course, is going to fly by a little asteroid named Dinkinesh, and it's a main belt asteroid. But the real goal of Lucy is, at the end of this decade, is to explore several what we call Trojan asteroids. And they're Trojan because they kind of hide, right? You find the Trojan asteroids leading and trailing Jupiter in its orbit around the sun. Interesting fun fact, those asteroids, even though they're in Jupiter, the orbit that Jupiter's in around the sun is actually closer to Earth than Jupiter. But those asteroids are incredibly important for telling us about the early part of the solar system, where the giant planets were and if they migrated or moved over time. Those asteroids were picked up and held in that gravity field over time. And so the different asteroids we're going to visit will tell us about that history.
Exactly. A lot of great things going on with asteroids right now. Nikki, Lori, thank you so much for being here.
Go Psyche.
Go Psyche!
Of course, go Psyche. Jim and Megan, back to you.
I love to see how excited they are. I also love that we do have this big screen there that's showing you the trajectory again of that second stage with Psyche. Now, we are 33 minutes since launch. Once this Psyche spacecraft is on its own, the spacecraft will use solar electric propulsion to move through space. Now, that's a super efficient system being used for the first time beyond the moon. First, Psyche's solar arrays will convert sunlight into electricity. That electricity will power the spacecraft's 4 Hall thrusters. Those thrusters will use electromagnetic fields to turn Psyche's propellant xenon into thrust, and that thrust will gently propel it through deep space while emitting that cool blue glow you just saw there on your screen. Now, Jim, when we're talking about gently, it is very gentle. Can you tell us about that?
It is very gentle. How gentle is it? It's so gentle. Hold out your hand.
Okay.
I have 3 quarters here.
All right.
It has about the same amount of force as those quarters.
Feels like nothing.
Nothing.
Absolutely
it's like
nothing.
a bag of feathers,
Yeah.
right? I mean, it's very, very gentle. So tiny but mighty, right? Because you exert that force over time, just continuously. So instead of just like one big main engine burn, it's just a slow, gentle process with that beautiful blue glow.
Yeah.
And that accelerates us out to like 125,000 miles an hour on our journey out into the solar system.
And that's essentially because even though it's nothing, if there's no atmospheric drag to push it back, it just keeps accelerating.
Exactly.
Interesting. Wow. Now, Maxar Technologies supplied Psyche's 4 Hall thrusters. You can see them there. Engineers estimate that if this mission used traditional chemical thrusters, it would have burned through about 15 times as much propellant. Now, Psyche is carrying 3 science experiments on board. Check out how they'll discover the asteroid's composition without even landing on it.
Psyche is a unique object in the solar system.
To us, Psyche is this really unusual body giving off really unusual gamma-ray neutron signatures.
Technically, it's an M-class asteroid out between Mars and Jupiter.
One of the first things you want to know is what's it made of.
So the Psyche payload consists of 3 science instruments. One of them is what's called a gamma-ray neutron spectrometer. It's actually 2 separate pieces of hardware. One is the gamma-ray spectrometer and the other one is the neutron spectrometer. Both combined study the elemental composition of Psyche.
If you know the surface composition, what it's made of in terms of iron and nickel and silicon and oxygen, you can then start to say something about its history and how it formed and how it evolved.
By using gamma-ray spectroscopy, we can measure those elements remotely. We don't have to touch the surface. We don't have to dig into the surface.
For Psyche, we're building kind of what we call the Cadillac. It's a very high precision, high sensitivity instrument. It's very similar to the Messenger instrument.
That technology that we developed for the Messenger spacecraft gave us a huge head start going to Psyche.
For our types of instruments, we don't get to fly them very often. So when we actually get selected for something, that's a big deal for us, where we can, take what we learned from the prior missions and implement it now and make an even better instrument.
Our instrument is kind of like a camera without a telephoto lens.
In order to get our best measurements, we need to be relatively close altitude above the surface. That's what we call orbit D.
So we can form maps, global maps, of the elemental composition of Psyche just by flying around externally.
You have galactic cosmic rays. That's a fancy word for very fast protons. They come in, they smack a planetary surface, they bust apart the atoms in that surface, all the neutrons rattle around, and as they rattle around, they end up producing gamma rays and neutrons that come out. And the gamma rays have energies, and they're like a fingerprint. So if you get the fingerprint of different energies that says, is iron there, is nickel there, is silicon, and then how many of those gamma rays tells you how much of that element is there.
The first thing it takes to do a mission like this is a tremendous amount of institutional knowledge of all the different aspects, not just how do you build something, how do you aim something, how do you guide something, how do you get data from something, those technical aspects.
I feel like it's super important to have a team that you can trust, because you can guarantee that at some point something's going to go wrong, probably many things over the many years of a project. So already it's happened that in my process of learning about the science, I've made small changes to the design to help optimize and help meet the science goals.
We're kind of the last instrument to get its measurements.
And so there is a sense where you're on pins and needles until you get that data back, and then there's a big relief, there's big excitement, and then you get to work and trying to say, what does all this mean?
So we'll deliver some excellent science at the end.
And active checkout of the instruments starts about 6 weeks after launch. Jasmine Hoffington's got to speak with NASA's chief scientist, Kate Calvin.
Welcome, Kate. Thank you so much for joining us today. So PSYCHE is going to take us to a metal world for the first time. What scientific discoveries are we looking forward to?
Well, the PSYCHE asteroid could be the metallic interior of the remains of a small planet. So this will give us an opportunity to understand how planets like Earth formed. So 4.5 billion years ago, all the planets on our solar system formed from the same cloud of gas and dust. And Earth has a metallic interior, but we can't bore down deep enough to see it directly. And so by visiting PSYCHE, we have this window to understand the processes that led to creation of planets like ours.
And it's going to take us a while to get to PSYCHE, about 6 years. So what are the long-term benefits of a mission like PSYCHE?
Well, from a science perspective, scientists are hoping that it'll help us better understand planetary formation, including the formation of planets like ours. But PSYCHE also has a technology demonstration along with it. So it'll be a test of communication from space, the next generation way of communicating from space. So the deep space optical communication will be the first test of laser communication from out beyond the moon.
Right, so we actually have two firsts attached to the PSYCHE mission, PSYCHE and DSOC. And once we get to the asteroid, we're going to be taking all these pictures, and then those pictures will be open to the public. So why is it so important that NASA makes science accessible for everyone?
So NASA makes its science publicly available, and we're working across the agency to make it more accessible so that more people have access both to the information, but also understand what we do with that information. And by opening science up to the world, we can do more and do it faster. So when we bring more people in and include them in our science, we can ask more questions. We can also answer questions more quickly. And this isn't just something we're doing with PSYCHE and with planetary science, but we're doing it across the Science Mission Directorate.
Exactly. We're actually doing it with Earth as well. We have the Earth Information Center now at headquarters. Can you tell us more about that?
Yeah, so PSYCHE is going to give us a little more information about metallic cores, and Earth has a metallic core. What the Earth Information Center tells us is a little bit more about what's happening on the surface of the planet and what we can see when we observe Earth from space. So we can learn about things like land use and land cover, we can learn about ice, we can learn about what's happening in the atmosphere and how that all impacts people here.
Exactly. Thank you so much for being here with us today, Kate.
Thank you for having me.
NASA and the PSYCHE mission team love engaging with the public and especially students. One program invited undergrads to share their creative works inspired by PSYCHE. So let's take a look at some of those submissions now.
Yeah. This is awesome.
That's so
I love
cool.
the way that we have artists and dancers and poets
Yeah.
and writers and playwrights, and this is spectacular, beautiful views. There's
the colors
there's our
for this
mission
one is
color
great.
theme right
Yeah.
there. Yeah.
And I love 16 PSYCHE is scripted right there,
Yep,
really
with
pretty.
the spacecraft with its deployed solar panels.
Yeah.
Yeah, this is just beautiful stuff. Look at
Oh,
that.
that's cool. Look at the detail on Psyche there. Are your pictures going to look as good?
Just exactly. Yes, we certainly hope so. But boy, it's just beautiful fun to imagine.
Yeah, and it's so cool to see that both science and art, they can inspire one another.
Absolutely.
So,
Expect lots of signal, hard to beach stock.
Now, if you want to see more artwork and other projects inspired by Psyche, take out your phone and scan another QR code we have for you on your screen. This one's going to take you to psyche.asu.edu/get-involved. Okay, and I do know that you have other space arts. You're just so full of demos and props. I love it.
Space rocks, right? So I have a couple more space rocks. This is a slice of an iron meteorite. Let's see if I can hold it up to the camera there. It's a slice of an iron meteorite that's been polished. And you can see the beautiful grains. There we go. You can see the grains in it.
So
and this is a mixture of metal and silicate rock.
Yeah.
And so this might be not polished, but might be what the surface of Psyche is like.
Oh,
but it's also,
interesting.
it's just beautiful. People put these on their mantelpiece and in their rock collections. You can collect these.
You said make
as
it
well.
jewelry too,
You can
right?
make jewelry out of them, little earrings, a pendant, whatever.
That's cool.
I have another piece of space art. This is also a space rock. Let me hand this one to you. Tell me what you feel.
Oh, that's heavier than I expected.
Very
Wow,
heavy,
that took
right?
me
It's a
aback.
sphere that the artist has kind of carved out of a much bigger metal meteorite, and you can see all the little grains.
Yeah.
And it almost looks like a little mini Death Star,
It does.
right?
It does, actually.
And so people collect these and trade different ones with their friends, and so there's lots of ways to use space rocks for art too.
Yeah, thank you for sharing those. I really
Sure.
appreciate that.
Sure.
All right, it's now been about 44 minutes since launch. Our coverage is again going to take you through the deployment and first possible signal from the Psyche spacecraft. So let's check back in with Mission Control at NASA's JPL.
Thank you, Megan. Welcome back to JPL. We may be 2,500 miles away, but I can tell you the community feels connected. And here's a live look from Von Karman Auditorium. Just moments ago, it was packed with nearly 200 family and friends. This is where JPL hosts special events, and it's also where we display several spacecraft models. And there's a model of the Psyche spacecraft that I had a chance to see up close with payload manager Noah Warner. Take a look at why he says you can compare parts of the spacecraft to an electric car. Great to have you here, Noah. Tell us more about Psyche.
Yeah, I'd love to. So we're standing here with a quarter scale model of the Psyche spacecraft. And you can see even at a quarter scale, it's a very large spacecraft. The actual Psyche spacecraft is over 15 feet tall and 80 feet wide, and at launch it weighs over 6,000 pounds fully fueled. Let me point out a few key features of the spacecraft. You see up top here is the high gain antenna under this silver blanket, and on front is one of our 3 low gain antennas. Also on the front of the spacecraft is the NASA technology demonstration instrument called Deep Space Optical Communications.
Psyche will use a special kind of propulsion system. What can you tell us about it?
That's right. We use solar electric propulsion. That means we gather energy from the sun through our 5-panel solar arrays. We convert that energy into electricity and use that electricity to drive our Hall effect thrusters, 2 of which you see right here. They're 4 to 5 times more efficient than a chemical rocket. You can think of a chemical rocket almost as like a gasoline-driven, high-performance sports car with lots of acceleration. Whereas our Psyche system is more like your highly efficient electric car that gets you everywhere you're going on the minimal amount of fuel. Hall effect thrusters use xenon as the propellant. They ionize that propellant and accelerate it out at tremendous speeds. They also generate this beautiful blue plume.
Wow, and right now it's packed up in the spacecraft. How do we get it to look like we see it right now?
That's right. At launch, these 5-panel arrays are stored flat on the side of the spacecraft. And a series of cables, springs, latches, and dampers will choreograph that deployment such that the first 3 panels in line here will deploy first, and then the side panels will come out one at a time after that. And then the spacecraft will start looking for the sun and get those arrays pointed directly at the sun to get full energy. At that point, the spacecraft starts a rotisserie move where it rotates about once an hour, establishes communication with the ground, and then the operations team can start to check out the spacecraft and get Psyche ready for its journey.
So what are you looking forward to on Psyche?
I think I'm looking forward to the science investigation and frankly, the fact that we're going to a world that we've never seen with our own human eyes. We don't really know what we're going to see there, but I think we've got the exact right suite of science instruments to figure it out once we do get there.
Thank you, Noah.
Riding along on Psyche today is NASA's Deep Space Optical Communications Experiment, or DSOC. It will be the agency's first test of high bandwidth optical or laser communications between Earth and beyond the moon.
In our everyday lives on the ground, we use optical fibers for really high-speed communication, and that capability has been adapted for use in space near Earth. DSOC stands for Deep Space Optical Communications, which is using lasers to communicate at high rate, and the application of that to deep space beyond the moon is what the DSOC project is about.
Primary objective is to give future NASA missions the tools for returning data at much higher rates.
The signals travel at the speed of light, so they come just as fast as they do for the microwaves, but you could send more data in the same time of a pass for the same spacecraft resources. The notion of being able to communicate, have video to astronauts on Mars is actually part of the vision that NASA has for optical communications. DSOC consists of a flight terminal that flies on the Psyche spacecraft, and then a ground network that has a station for transmitting up to the spacecraft and then receiving the laser signal down from the spacecraft.
Here we have to send a laser beam from Earth that the spacecraft has to receive, use as a pointing reference, and then initiate the communication link. So it's a very flight and ground joined at the hip kind of telecommunication system.
DSOC is being implemented as a technology demonstration to show that we know how to build terminals that can do this, with the idea that in the future they can be flown as part of the operational communication system on future missions. And we designed the terminal to operate out to about Mars' farthest distance. And Psyche on its cruise actually does a Mars flyby, so it's an excellent vehicle for the demonstration of deep space optical communication. DSOC is the first time that there'll be optical communication demonstrated beyond the moon.
The leap that DSOC is taking is huge. I can't express in words, what this will mean to actually see bits that were transmitted from deep space spacecraft received on the ground, and we can verify that, hey, we got the bits that you sent, here they are. Before that moment of elation and joy, there's a lot of work that we still need to do and think through.
And so this is a stepping stone for a future operational capability that NASA's committed to. There's a lot of activity in space and a lot of collaborative work that goes on, and it's very exciting to be part of.
MVAC engine chill, burn 2.
Now to tell us more about DSOC, we have its operations lead, Meera Srinivasan, with Jasmine.
Thank you, Megan. So Meera, we just saw a beautiful launch, but now the work really starts for DSOC. So what does mission success look like to you?
Right. So, the purpose of doing optical communications is to be able to transmit much higher data rates than what we can do now with radio frequency systems. So, for us, the bottom line or ultimate measure of success would be for us to demonstrate those target data rates that we've established for ourselves over the course of the mission. But just to kind of beyond that, I think this is a technology demo. So what we really want to do is learn. And we have deployed all kinds of technologies, both on the flight side as well as on the ground side, in order to achieve these goals. So really, what we'd like to do is get enough data back so that we can understand, do our models work, how does our hardware perform, and what we can do to improve our operational concepts so that we can kind of mature this technology and bring it to the point where it can be fielded operationally. So that's mission success, is basically learning as much as we can.
Right, we're looking forward to that. And you're mentioning this data, so what information will DSOC be transmitting?
So what we're going to be focusing on primarily is this kind of test pattern data. This is what we've been using on the ground as we were developing the system, and so we'll focus on sending that initially. It's essentially like it's a test pattern, something that's pre-recorded, and it allows us to characterize the performance of the optical channel.
Right, and Meera, this is going to be a long-term mission for Psyche, but how soon do we expect to hear back from DSOC?
So provided that all the checkouts go as planned, approximately 40 days after launch, we hope to be getting some data down.
Okay, great. We're looking forward to that. Meera Srinivasan, thank you so much for being here today.
Well, thank you for having me.
Of course. Megan and Jim, back to you.
Now let's get to some social questions again. Jim, you've been doing a great job of answering them, so I hope you can continue your streak.
Let's do it.
All right, let's play the first video.
Hi, I'm Diego, and I'm from Serrano Elementary School in Moreno Valley, California. My question is, how long will it take Psyche to orbit the asteroid?
Good question.
Diego knows how to ask good questions. Absolutely.
Orbits.
Yep. So we start up very, very high as we approach the asteroid, go into very high orbit, and it's about 33 hours for the spacecraft to go around Psyche once, and we'll slowly lower that orbit, lower, down to about 4 hours. We're about 75 kilometers, maybe 50 miles or so above the asteroid at our lowest orbit.
Okay, and we do have time for one more question. We have this one from X, Space Case Sarah on X. What are you most excited about to learn about Psyche, considering how the Bennu sample was so incredibly cool?
Yes, boy, what a great success for that,
really
for
cool
the
too.
OSIRIS-REx team. That's spectacular. Of course, we're not taking samples from Psyche. We're doing what's called remote sensing, but we will be able to measure the chemistry, to look at the geology. We'll be mapping this asteroid just like the OSIRIS-REx team did with Bennu. So we'll learn as much as we can just short of bringing a sample back. So maybe in the future, decades hence, maybe we will go and bring some samples back from Psyche. But this mission will pave the way for that.
Okay, looking forward to maybe that.
Let's do it.
All right, thanks again. If you haven't sent in questions yet, there's still time. Again, use hashtag AskNASA. Okay, we've been following along with the Falcon Heavy's second stage as it continues its journey out with Psyche. Let's bring back NASA's Daryl Nail and Mick Wolfman
burn 2.
for the next operational milestones in this mission. Guys, go ahead.
Yeah, and there you just heard it, and you can see it. The engines start for the second time on the second stage of the Falcon Heavy rocket, now flying through space close to the country of Australia. And you can see it there. We've been tracking it all along, watching the fuel get prepped and prepared to restart that engine. Mick, this burn, roughly about 2 minutes and 9 seconds.
Yeah, this burn's very important to get Psyche on its way. And Daryl, as you said, we've been tracking that. And as throughout that 45-minute coast phase, there have been call-outs for different ground stations that have been used around the United States, or around the world, actually, to track this second stage. And you and I have been continuing to watch that telemetry. And this vehicle so far has performed very well today, and looking forward to this final burn to get ready for spacecraft deployment.
Those tracking stations that you mentioned, as we've heard them called out throughout the broadcast, also helpful with bringing us this picture right here, that high-definition video pictures from space, which we greatly appreciate seeing and are able to show you exactly what's happening. As the spacecraft approaches the northwest coast of Australia, it will continue flying over the Indian Ocean. We will get ready to end that second burn and then prepare for the big moment, Mick, and that's separation of the Psyche spacecraft.
Yeah, and that's what Jim and I know all his team are excited about. We are too. Great successful launch today, watching that Falcon Heavy come back, those two side boosters land. But it's all about the Psyche spacecraft in this mission, and that's what we're very happy to be doing today, to deliver this on orbit and get Psyche on its way. And we are so happy to be a partner with JPL and the Psyche team to do that. So very looking forward to that video of separation.
So the burn about to come to an end here in just a few seconds.
MVAC shutdown.
There you hear the good call out of the MVAC shutdown. Still glowing red, though, in the cold darkness of space. We are in orbital night on the other side of the planet from where we launched this morning.
Nominal payload deploy, orbit insertion.
Confirming the orbital insertion there.
So yeah, it's confirming that we hit our mark exactly on that trajectory and where we needed to drop Psyche, get ready to drop Psyche off, as Jarmaine had pointed out earlier in a segment on the trajectory. So that's really good to hear that Stage 2 performed perfectly today, and we're getting ready for this last little coast prior to Psyche deployment. As you can see, the spacecraft right there on the front of Stage 2.
Yeah, there it is, the Psyche spacecraft attached to the second stage, the camera looking forward where we can see. That will be the image we will be looking at when separation happens, and we'll be tracking that as it goes along, of course. We lifted off today at 10:19:43 a.m. Eastern Time, 14:19:43 UTC time, and we've been flying for almost an hour now. And again, the teams at JPL certainly paying close attention, along with both here in California, or there in California and here in Florida. They're locked into this moment about separation.
Yeah, spacecraft team I know is excited about this moment, and the launch vehicle team is actually continuing to watch as they secure the launch pad here, and everything's going well. So teams are excited for this moment here. This is what it's all about, spacecraft separation.
And here is some of that team at the Mission Director Center in Florida, and now you're looking at the team in Pasadena, California at JPL, the Jet Propulsion Laboratory. Now, this is the control room where they will run Psyche. We'll be monitoring the second stage and Psyche as they fly, and we'll be back in just a little bit. But for now, we'll send it back to Megan and Jim.
Really loving those live views that we're seeing of the spacecraft there. So why don't we actually, head back on over to JPL in California to hear what's happening now as they check out the spacecraft.
So the SpaceX speak, you just be like, it's green, we're okay.
Thanks, Megan. We are about 1 hour after launch, and now everyone at JPL is eagerly awaiting the next major milestone. Here is a live look from our mission support area. There was a shift change just a short time ago. Right now, they're preparing for initial acquisition of signal from the spacecraft. I'm joined now by Psyche Flight Systems Manager Mark Brown, who is responsible for spacecraft development. Thank you for joining us, Mark.
Thank you, Raquel.
Now, you were part of that countdown shift.
Yes.
What was it like witnessing launch with your team?
Oh, it was very satisfying. The end of a long road for us developers, but then this is the start of the journey, that the spacecraft's going to take. We're very confident in how the spacecraft's going to behave. We've done all the testing and analysis that relates to this. There's always a little bit of nail biting that goes on with these things because you can't exactly test that exact ride to space, but we're quite confident. The other thing I would say is that we're relieved to have gotten to do launch today. There's a lot of moving parts with these launches. As you know, we got people in Florida, people here, people working off shift times, and just knowing that we're launched will allow everybody in their personal lives to kind of settle down. We now know what the schedule will be, going on from here. So.
And what can we expect to see next from Psyche now that it's started its journey?
Right. What's really going to happen just in a matter of moments is we separate from the launch vehicle, and now the vehicle's really on its own. On the ride up, it was on battery power. So when we get those solar arrays deployed, we'll be looking to basically get to the arrays on sun, okay? And then we'll be looking for that first signal. And the first signal isn't necessarily a data stream like you would think about. Anybody of you that, in your house, if you're looking for your Wi-Fi, you can see that signal, but you don't necessarily start getting, Google and on the internet, right? So the carrier comes in first, and then we'll kind of sync up and we should get the data coming in.
And what kind of data will you expect to see from Psyche?
There's a range of, first of all, I'll say, is that, the spacecraft exists to carry the science instruments, but the science instruments are hibernating. They are off for launch. So we don't really see anything from the instruments themselves. We get some temperature data and, and some health data on those instruments. But what we're probably most interested to see is, are we power positive? Is the battery recharging, or are we still draining it? And then we're also going to be looking for, are all the temperatures kind of within safe limits, nothing too hot and nothing too cold? And those will be big indicators of, that we're good to go.
Well, thank you so much for that information, Mark, and joining us today.
Right. Thank you.
Back to you, Megan.
Okay, well, as Mark said, we are soon expecting to see the Psyche spacecraft separate from the Falcon Heavy's second stage. We have an animation of that right now. Let's bring back Daryl and Mick. Everything still tracking, guys?
It certainly is, Megan. We are watching now, as you can see on your screen, the Psyche spacecraft looking forward from the second stage, as well as keeping a track on what's behind it as well, going between the two views. But
acquisition of signal, Hobart.
And there's just a call out that they've reached their next tracking station along the path that Psyche is taking. But the big show is right there. That shot right there, Mick, the Psyche spacecraft. Pointed into space. We are in orbital nighttime, currently flying. We've overflown Australia, approaching Papua New Guinea, where we are tracking a separation time in just about in just a few seconds. Stand by.
Psyche payload separation confirmed.
There it is. The Psyche spacecraft going off into deep space.
That is
2.2 billion-mile journey.
Yeah, I'm going to tell you that is an amazing shot right there. It is so. I'm so excited to see that. Probably not as excited as Jim, who's up at the host desk right now, but that is an awesome shot to see Psyche leaving the stage 2.
You see the team right there in the lower left-hand right corner. They are anxious as they see their baby go off into space towards an asteroid named Psyche, same as the mission. As you look at that Psyche spacecraft, you see the large diameter circle, which is where it attached to the payload adapter. That circle down at the bottom, that's a low-gain antenna. And that low-gain antenna will play a key role. It's got 3 of them. There's 2 more on either side. So if that one is the bottom, there's 2 on either side. It will play a key role on when we get that carrier signal that we just heard JPL talking about.
Yeah, I'm going to tell you, in all my years of doing launches, Daryl, that was a beautiful sight. I think that's the longest I've been able to see a spacecraft deploy. So that's an amazing job by the SpaceX team on that camera work on the second stage.
And so we'll keep tracking this as well, listening in for that signal. Momentarily, we're actually going to put up a waveform monitor where we're actually going to be looking at the signal, whether or not we can see, actually looking to see whether it comes in or not. That is a little more inexact because, as he described, JPL in the earlier interview, that spacecraft is going to start rotating as they try to lock that low gain antenna to a receiving station back here on Earth that JPL will see.
Yeah, I like the way he described it, like your Wi-Fi in your house, right? You find a signal, but you don't quite start receiving data and getting on the internet yet. That's kind of what they're looking for from the spacecraft here, that low gain carrier signal that they can know where Psyche is and that they've made contact with it, and then they'll continue to monitor that and so that they can then sync up and start getting the data and then starting their next 100 days of operation with the Psyche spacecraft.
All right, we just saw the Psyche spacecraft separate and go off on its journey into deep space towards the Psyche asteroid. We are now monitoring its progress to see when it makes that carrier signal back down to Earth, but we'll send it right now back to our other Earth partners, Jim and Megan.
Well, Mick had said it. Mick, there was a lot of excitement here when we saw Psyche separate. But now I feel like there's a little bit more of an anxious feeling because now we're waiting for the carrier signal, right?
Yeah, so we've just seen this beautiful wild animal released into its native habitat.
Okay.
Right? This is where that spacecraft belongs. This is what it was built for. Let's see if it phones home and we get it going.
Yeah, exactly. Yeah. And while we wait for that, why don't we take some more social questions? Again, we've asked people to send them in using hashtag AskNASA, and we've gotten a couple of them. So why don't we show the first one now?
Hi, my name is Santiago, a student from Ted Porter Elementary School. My question is, why do you guys think Psyche is a core of a planet?
Wow, these kids are asking awesome questions.
I know, I love seeing
Santiago,
kids
that's a
ask
great
these
question. So there's 3 pieces of evidence. One, we can see the colors, the way that the asteroid reflects sunlight. Looks a lot like those metal meteorites I showed you earlier. Also, astronomers can bounce radar waves off of Psyche from the Earth all the way out to the main asteroid belt, and they bounce back, and very, very highly reflective, not quite like a mirror, but clearly suggesting metal. And the third piece of evidence is that when we can watch its orbit wiggle a little bit when Mars passes by, or when Jupiter passes by, or when Psyche passes by another asteroid, its orbit changes a little bit. So we can get its mass, we estimate its volume, also from telescope data, and that gives us an estimate of density. And its density, it's heavy. It's not that light granite rock, right? It's more like that heavy metal meteorite, that sphere that you held, right? It's really dense. So we know that there's a metallic component in this one as well. It's one of the densest asteroids we've been able to measure.
So you guys do know a lot about it. Now it's about going out there and checking out to see if your hypotheses are correct.
True. It's still a point of light to us in the sky. We have to get close to it to turn it into a real world.
Okay, let's take another social question now. This one is from Christelle on Twitch. Is there a chance that the asteroid contains water?
That's a great question.
Yeah.
We don't really think so.
Okay.
But it might have some material on the surface that is more silicate rich, not so metallic. Maybe it was hit by other meteorites like the one that we just brought the samples back from OSIRIS-REx, which turns out to have a bunch of water in it. So there could be little places on the rocky parts of PSYCHE that have some water, but probably as a whole, we think it's mostly just metallic.
Got it. Jim, thank you so much for answering those questions, and thank you to everyone who sent questions in. Okay, so to recap, the PSYCHE spacecraft has been deployed and is now floating out in space on its own. The launch team is looking to confirm a signal from the spacecraft. So Daryl and Mick, how's that looking?
Yeah, Megan, we've been flying for 1 hour and 8 minutes now through space. And there you see, I believe we have
Yep, I see
a signal.
See the spike right there, the low carrier signal, and the JPL team clapping. It looks like that little spike in the center right there is the low carrier signal that they're looking for. So that is good news that we've received that carrier signal, and the team will begin their work.
And what you're looking at there in the lower left-hand corner of your screen is the receiving station for JPL, and they got that carrier signal, which came off of PSYCHE's low-gain antenna. It sent out that signal. There's not a lot to that signal. There's no data, no telemetry, just a basic signal that says, hey, I'm here, I'm out in space.
Yes, basically, as Jim said, phone's home, lets them know where they are, that they can start working to get their stuff set up and start acquiring data later on and beginning that next 100 days of operations that they need to do. So, very excited for the PSYCHE team, spacecraft team. Successful launch of a Falcon Heavy today, and now they have contact with PSYCHE, and they can begin the work they've been working on for the last several years.